Okay, so I was talking about the level of indirection a while ago. So to give you an example about levels of indirection, here is one example. Okay, so car 1 here has a level of indirection 0 because you do not see any asterisk attached to it in its declaration, which means that when you want to access the value A, you just simply use the variable name car 1 with no need of any dereferencing operator. Okay, so while PTR1 here has one asterisk attached to it, so therefore its level of indirection is 1. Okay, because when you want to dereference the value that it points to, you need one asterisk attached to it. Okay, then PTR2 has a level of indirection 2 because you need two asterisks when you dereference the value that it points to, and PTR3 has a level of indirection 3 because you also need 3 asterisks attached to it when you dereference the value that it's pointing. Okay, so by the way, the data type of car1 here is char, the data type of PTR1 is pointer to char, and the data type of PTR2 is pointer to a pointer to char, and the data type of PTR3 is pointer to a pointer to a pointer to char. Okay, and the next line of statements here are the valid assignment statements. Okay, so PTR1 can be assigned with the address of car1, and PTR2 can be assigned with the address of PTR1, and PTR3 can be assigned with the address of PTR2. Okay, you cannot assign PTR2 with the address of car1 because the level of indirection of PTR2 is 2. Therefore, the addresses that you can assign to PTR2 should have a level of indirection equal to 1. Okay, in the same way that you cannot assign PTR3 with the address of PTR1 because you can only assign addresses to PTR3 which has a level of indirection that is 2. Okay, so that you would know which assignment statements would be valid. Okay, so just remember that the left hand side, the level of indirection of the left hand side should always be 1 greater than the level of indirection of the right hand side. So meaning to say, if PTR1 is 1, then the level of indirection on the right hand side should be 0. If PTR2 is 2, and the level of indirection of the right hand side should be 1. And if PTR3 has a level of indirection 3, then the level of indirection of the right hand side should be 2. Okay, so take note of that. So the level of indirection of the left hand side should always be 1 greater than the level of indirection of the right hand side. Okay, so let's take a look at the values of the cells here. So car1 has a value A. Okay, then assuming that its cell address is 4433, PTR1 initially has no value yet, so it's null, and it's located at address 1990. PTR2 is also null, and it's located at cell address 2727, and PTR3 is also null, which is located at address 9994. Okay, so when you execute the statement here, PTR1 now will have the value 4434. Why is that? It's because PTR1 will be pointing to the value A. That's the result of assigning the address of car1 to PTR1. Okay, so if you want to access A, then you need to follow one arrow to be able to access A. Okay, so PTR2 also here will have the value 1990 when you execute this statement. Okay, so PTR2 will be pointing to PTR1. So if you want to access A, you need to follow two arrows. So 1 and 2. Okay? Then PTR3 will have the value 27, 27 when this line is executed, and it will be pointing to PTR2. Okay? And if you want to reference A, you need to follow 3 asterisks. So 3 arrows. So 1, 2, and 3. That's the level of indirection. So when you output or display this statement here, or execute the statement here, so it will display the same values. car1 will display A, asterisk PTR1 will display A, asterisk asterisk PTR2 will also display A, and asterisk 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 PTR3 will also display A. In short, these 4 here are called aliases of each other, meaning to say that you can reference the value A in 4 ways, using car1, PTR1, PTR2, and PTR3. Okay, so that's about levels of indirection, or pointers to pointers. Okay. So how about pointers as arguments to functions? Okay, so we can pass a pointer to a function to simulate pass by reference. So before we do that, let's have a review first about pass by value. So remember, in pass by value, we just simply pass a copy of the argument to the parameter of the function. So for example, if you have 2 functions here, main and add. So for example, in main, you have 2 variables, num1, okay, sorry about that, num1, which has a value 25, okay, and you also have num2, which has no value yet, okay. Then in add function, it has 1 formal parameter, number, okay. So in pass by value, when this function invocation is executed, it will just copy the value stored in num1 to the formal parameter of the function add. So if num1 contains 25, so number, the parameter number, will also contain will also contain 25 here. Oops. Okay, so anyway, okay, so here also, oops, I don't know what's happening. Anyway, okay, sorry about that. So this one will contain 25, okay, and then you increment the number here, so this 25 now will become 26, okay. And then since you have a return statement here, so basically the value 26 will replace this function call. So the function call add with argument num1 is actually 26, and that 26 will be stored in num2. So that's passed by value. So the value that we use, which is 25, is not affected in main. Okay,